Okay, so that's our call. Just quickly about me again. So, as you guys know from my AWS events, I lead and know create organize events on the AWS communities, largely on container topics and also security topics. I'm originally from India, but I'm Indian British. I have my home in England, and yeah, my second home is now in Hungary. So yeah, I traveled across U.S., Europe, and Middle East. I've lived and worked there in those places as a contractor. So I've worked with multiple customers on different sectors. Uh, that's a good opportunity for me, to learn various cultures, yeah, various aspects of IT, how they, work, how they operate. So that was really good learning for me during this last decade or two, which also helped me. I'm also AWS solution architect and a security specialist on Amazon Web Services. I also lead the container services within T-Systems as a product owner for yeah, Docker, Kubernetes, ECS, EKS, and OpenShift, Rosa. We create value-added services for the customers, which I'm leading that aspect as well. So I have experience working with most of the hyperscalers, AWS, Google, yeah, Microsoft, and I have also worked with a lot of service integrators, partners in the cloud migration journey. So yeah, that's me in a nutshell. I'm more passionate about bringing the communities, local communities together, share knowledge. Yeah, so I help each other, learn from each other. So I really like this kind of events where we, bring various backgrounds, technical backgrounds, dev guys together, share our knowledge, yeah, learn from each other. I really like this community events where we benefit from each other. Okay, so today I'm going to talk about container security, vulnerability scanning. So this is in more a level next on what Thalia has already covered. So first thing is like, what are vulnerabilities? Yeah, how do you would like to view them? How you address them on a high level where Thalia has gone through, and how you basically use Snake to address those most of the vulnerabilities as well, right? So that's what I'm going to cover. High level, I would like to stress on the cloud native security white paper. So the CNCF, they published a white paper version 2 last month or beginning of this month, a new version. I would like to highly cover on a very high level on what it talks about, what they recommend to do, yeah, on the four life cycles, they call it, and, very high level, not too much detail, but I'll give you the link on the white paper. Feel free to learn. I like it. How they recommend, how they advise. And we quickly go on the Dockerfile best practices. So any container you build, so this is the basis if you're using Docker to create any of your container images. On a high level, we go through what are the best practices to create your Docker file. We use yeah, wherever you host your containers, so you have to make sure you harden your host where you're running those containers. So we will look into two open source tools where we can use to harden your Docker host or your container host where you're running your images using Docker Bench and Kubebench, one for Docker and the other for the Kubernetes. We also use learn about some open source tools, how you can make your container images more secure and more smaller and secure as well. So I would leave the snake bit because we already covered, but I would cover more on the open source plus Amazon Elastic Container Registry service as well. And we will go through the container services where you host on how you host or how you run on AWS, very high level, but we concentrate on ECR, Elastic Container Registry, or we automatically get some security alerts based on the images you push. And we look into EKS, Elastic Kubernetes Service, on Amazon, what are the best practices are. I know a lot of guys are from Kubernetes background, container background, so I thought it would be, a little useful. So we concentrated on the EKS and yeah, mainly on the security aspects. Before you host anything or your pods in your EKS, what are the security, responsibility metrics, and we'll come to the questions. So first, CNCF, yeah, white paper, security white paper. So what is it all about? So first phase they talk about is the develop phase. So any security for cloud native applications that needs to be applied throughout the life cycle of your application. And the first phase would be the develop phase where uh, it's resulting in the creation of your artifacts like infrastructure as a code or your images, your manifest files, right? That will be used to deploy and configure your cloud native applications. I'm just referring to cloud because we are referring to AWS or cloud native aspects here, but it can be your on host or in your data center or anywhere, but you still consider some security aspects. But subsequently, these artifacts have proven to be source of numerous attacks where it can be exploited in the runtime. So this they go in more detail in the white paper. I would like to you to just go through it. What they the more aspects with what they cover on this develop phase. I would move to the next on the distribute. So this distribute phase is basically where you're responsible for consuming the image definitions, specifications to build the next stage of the artifacts, such as the container images. So where, uh, yeah, so VM images or anything that's the output of your build stage or your develop stage. Yeah, and in modern CI/CD pipelines, usually the distribute phase consists of the systematic application testing, as you can see in the third row, where you basically you do your unit test, integration test, system test, make sure they're okay. Otherwise, it goes back to the development and the cycle continues. Yeah, that's your SDLC, software development lifecycle. So once you identify, okay, I'm fine. We pass through the test. So you do some, you basically promote that into your next test phases. Yeah. So if you use more of a open source tools as part of your application process or in the development phases, there is more chance of vulnerabilities and malware that comes into your container images because you don't know how they build it, you don't not aware of how those images are signed. So that will be a problem within your application container images. So here, what they recommend is basically, to incorporate some sort of security process in the fourth column, as you can see. Once you got the image, so you should have another phase of security testing where you can scan your vulnerabilities for container images, yeah, infrastructure as a code, compliance scan, and also a manifest files and security compliance scan. So this can be done using various tools. So one of the tools can be Sneak, which my Talia has gone through, but I will show you some of the open source tools you could use as well. But the focus here is more on scanning your images, any threats, or validation of your integrity of your images of your application, and just protect them from tampering. Yeah, so that's the objective here. So organizers and on the image integrity, and you can go one further step by also introducing encryption of your software as well to make it more confidential, and more secure using some encryption keys and stuff. But that's beyond this. But you can also harden it more by using encryption as well. So the next phase is deploy. So once you're happy with those scans, you okay. So you need to promote them somewhere, right? You need to deploy them somewhere. So the deploy phase is basically responsible for incorporating a sequence of pre-flight checks, as you can see. So validate the image integrity, runtime policies, container policies. Yeah, so that applies for some Kubernetes. Some applies for your Docker images. You can also sign them, stuff like that. That will be deployed in the runtime environment where your test environment or your production, or mainly test environment before you put in the production. You have to make sure that complies with your organization security standards, or company, whatever compliance policies you have. You might want to run them, deploy, and you run those policies, make sure they're fit for purpose, and then, yeah, you promote that into your next step. So this, again, they've defined it very detailed in the white paper. I would like you to go through it. There are some standards which they also recommend to you, like CIS, yeah, Center for Internet Security. They also have some the benchmark scripts, which you will want to run those scripts against your images. Check this, yeah, security standards you've been compliant, or you have to go back to your development life cycle, change, do some changes, make sure it fit for purpose, and adopt some security best practices. So here, as I talked about host security, it's not just your container. So as soon as you install your image on your host, you also have to make sure your host is also fit for purpose on the security. There are no exploits, or less vulnerable to get hacked. That we will cover in some of the tools in the coming slides, and container security as well. So here, the pod security policies are Kubernetes network policy. Yeah, so if you're running any pods in your Kubernetes vanilla or in cloud, you might want to create an extra level of security by implementing I don't know, separate namespaces, tenant isolation. Yeah, you can the various things that you could use in Kubernetes, where you can implement yeah, container security. Some of them are here. And the last one is the runtime. So as you can see, the runtime phase consists of three critical areas. So one is the application, yes, the compute, and the other one is the access, how who you have access, and the third one is storage. So where you store, how you basically, yeah, what are the storage components you have. So while the runtime environment is dependent on successful completion of the develop, distribute, and deploy phases, the security of the runtime is dependent on the efficiency of the security practices, yeah, of the phases what you implemented. So it's not just on this runtime you just bring those secure, you're happy to run it, but you also have to ensure that the previous phases which you incorporated those security standards are implemented. You're happy, yeah, you have a certain criteria to accept them, and then basically, yeah, it's very important to adhere that, to finally to yeah, install them and make sure they comply. So yeah, on a high level, as you can see, on the compute layer, you have some kind of service mesh where you integrate. If you talk about Kubernetes mainly, how you integrate, how you control them, OS process control, network encryption. Yeah, so that's for the app and process, service access, and yeah, so memory protection, those stuff like that. On the access layer, on the cloud, you use identity access management. For any hyperscalers, you can control using authorization, authentication, and then authorization, what they can do. But here on the Kubernetes level, you can see RBAC, role-based access control. Yeah, at the control plane level, admission, network policies, port security. We have seen that in the previous slides. So image authorization, data volumes. So this can be on your access level. So once you have the authentication, okay, user one is authenticated to access my cluster. I'm just taking a Kubernetes cluster, and then you will have another level of control, which is role-based access control. What that user can do within your cluster, run the pod, or delete the pod, or create a new pod, that you can define in RBAC, yeah, in your config map. And especially network policies will adhere basically how you want to control your network traffic on where your pods are running. That's more secure. The port security, container security also defines how you would like to run your pods, and how, yeah, what other services that you would like to interact with, and you define the authorization there by creating some policies, yeah, and attached to those roles or users you would use in those environment. On the data, I would definitely suggest any data at rest should be encrypted using keys, encryption keys. In cloud, you have cloud native keys, or you use a customer managed keys, which you can also use. And also the traffic which is going between your application, which is data in transit. I would also suggest to encrypt that data using TLS traffic, yeah, uh, by using certificates. Either you can use cloud native ones. Most of the hyperscalers provide certificate managers where you can use to encrypt those data, and yeah, or you can use the certificate which your corporate standards, which your company uses. You import them, so you export them basically, and to the cloud, and you can also use encryption there for the data in transit. So, so coming to the Dockerfile best practices. So here I would say avoid any unnecessary privileges. So as I said, no, whenever you run Docker, so the default it takes as a root as a user, but the best practice is create a Docker user, set some group to it. There is some process where you can avoid using root. Uh, Also, do not bind any user identity or unique identity. Make executables one by root, not writable. So once you basically create an image or the end image, so you make sure it's not writable. So that's how the Docker image works in principle. Any layer that you would like to change, which you write in your Docker file, it basically changes only that particular layer, and it rewrites change that in your image. Yeah. Reduce attack surface. There's some of the aspects which Tali has mentioned, covered in the first session, where you must probably make sure the base images which you use to host your application on, like for example Alpine Linux, or I don't know, some JDKs which you use, make sure they are security compliant. Yeah. Or you build from your scratch, if you're more confident, if you want to have more confidence. And yeah, make sure you update those images very frequently, and be careful what ports you would expose. Yeah, so this is very critical, because yeah, this is very most common, where a bad actor or a hacker can get in and exploit your application by scanning your open ports and see how they can get in. So you have to be careful what kind of ports you want to expose for your application. That's where the good habit is. Wherever you have like a web application or something, your traffic ideally should end in your create a kind of a proxy or a load balancer, where the traffic from end user to the load balancer die. That will be encrypted, and you create another channel to your application, another traffic where that will be also encrypted, but it will be a different. Yeah, it won't be directly from the end user to directly to your application. So the recommendation would be use some sort of a proxy or a load balancer to serve your traffic from your end users, yeah, for your web applications. So never put secrets credentials in Dockerfile. That's common sense mostly. There's a recent incidences where users put the AWS secrets in GitHub. So what bad actors do is, they scan the GitHub repositories to find these access keys and secrets. So, and they exploit the AWS accounts. I don't know, running multiple EC2 instances, giving which will cost a lot for the guys who own those accounts. So you have to be careful where you secure those credentials in public repositories. There are some security best practices where you can use GitHub secrets. You have environment variables where don't have to expose them as part of your Docker files. So that would be a good practice. Or use you know some secrets manager, or for cloud native, you have a lot of tools which supports that. So parameter store, where you can save secrets manager, you can save those passwords, and then you call those variables in the runtime when you're running your containers. So that is also possible. So you don't expose your passwords or any secret database credentials. Yeah, so those aspects you wouldn't expose to the wider audience. So yeah, so this would be the Docker bench for security. So when you're running the containers in your production host, you might want to harden your image. As I said, it will be uh, using Docker Bench if you're running a production thing. So what Docker Bench does, it it's based on basically test all automated using CIS Docker benchmark. I don't know if it's the latest one, but I will provide you a link where you could download and get more info. But this basically scans your Docker host for any common configuration issues or any loose settings that you would expose any common vulnerabilities for exposures, and it gives you a rating or rank based on the result, and then you might want to fix them, and yeah, you would like to address them. So document is pretty useful tool. I use a lot on mine projects. I'm just watching a question here. So can you tell a little bit more about expose pros, how to check them? Yes, there's a they are uh, some open source port scanning tools as well where you could use to avoid those exposed ports. Not on top of my bed head, but I can definitely refer you to some tools basically which scans your local host, and it will give you some sort of metrics. What post is used by what? Yeah, is it really necessary? And you can check them. But the Unix command is basically netstat. I use netstat dash and tup, and it basically gives you all the. I will show you in a bit in the demo. But yeah, there are some tools as well which will also scan your ports on the host, and it will also give you some summary. Okay. Okay, the next one would be just to stay here a little bit to check on this document security on the right hand side. The picture, as you can see, that's my host. I want to make sure avoid unused images. That would be by Docker uh, kind of housekeeping. Any volumes you mount, you use your data. You have to make sure you unmount them, or you use a shared file system. You have to be yeah. You need to make sure port being outbound to expose to the internet 0.0.0.0. You have to be careful. On the container side, as you can see, the mount create a separate partitions for depending on your data types, data. Yeah, so make sure you don't put all the data together in one place. Or yeah, you can do not run SSH. So there are some Docker exec where you can go inside the container and you can do, but the practice is basically some of those vulnerabilities or the tools within that image, you can remove them to make sure more secure. And yeah, there are some tools which comes with that as well, the base images with very less or minimal. So I would recommend exploring some Alpine version of base images, which is very minimized version of actual Ubuntu or actual the OS which you would like to run on. The Alpine versions are a little bit thinner, contains exactly what you might need. For any additional things or tools which you might need, you can just also install them. But yeah, remove unessential services or any services which are running on your container. If you don't need it, stop them. Try to remove them. Limit memory and CPU usage. So you can also set your C and Docker stat. It will give you consumption or how they're doing. You can also allocate by default. It takes your host memory and CPU, but you can also set them in cloud native world. When you're running in Amazon Web Services, for example, you can set those limits depending on your application, and you can scale up, scale down as well depending on the usage as well. But that I will cover in a bit. Similarly, you have a kube bench for Kubernetes. uh, workloads, similar to Docker Bench. So if you have a host where you're running, this doesn't apply for cloud native because most of the managed services offered by hyperscalers, the underlying infrastructure is maintained by the cloud providers, hyperscalers. So this more on if you want to run your vanilla Kubernetes service, setup you have on your host, you have full access on your host where you have control. You might want to use Kubebench to run across your host, and then it will give you a nice summary of how how well is your how secure is your host. And again, this has some CSI benchmark standards which it will scan and run across, and then it gives you a summary as well. I'll pop up the links. Okay, so vulnerability scanning for container images, right? So far we talked about what's the security scanning looks like, or vulnerabilities. What's these white paper security thing? White paper says what kind of tools we can use for harden your host where you're running the containers. Now we're gonna go a level down to see before I host my container images. How can I scan my container itself, image itself, and make sure it doesn't have any vulnerabilities? And how do I address those vulnerabilities? So some of the tools which we touched about as well is Sneak, which my colleague Talia has covered most of it, right? And I'll skip that bit, but I will just quickly show you the Docker scan and the command line. But it just uses the Sneak CLI in the background, connects to the Sneak vulnerability database, and it gives you a nice summary as well. But I also tried to explore some of the open source tools where you could use, where you would like to have full control, no limitations that you would like to have. So I would also suggest Aqua Trivia. You can also use. It works on most of yeah container images. It also scans your file systems as well and Git repositories, and it gives you a nice summary. I can show you in the demo as well in a bit. But this is a nice little tool which I also use quite often. And the next one is the Docker Slim and Grip. Docker Slim basically scans your container image and try to minimize the size of your image. So it basically scans and analyzes your layers, what you kept on your Docker file. It understands or try to analyze, are they really required for your running application, or can you minimize avoid those unnecessary layers on top of for your application. So and it gives you a summary. Once you decide it, it basically get rid of all the unnecessary ones. They claim that it minimizes your doc image by 30 times, so which is pretty good, I would say. And I haven't used it much personally, to be honest with you, but I would definitely recommend for your applications which have big size, where you would like to planning to minimize it or understand what's in there with a nice summary. I would suggest Docker Slim. So Gripper is another nice tool for vulnerability scanner for your Docker images, container images. It can be easily installed. You can download them. You can also use it to generate your software bill of materials. And yeah, I will show you in the demo how the output looks like when you scan using Grip. I use less, to be honest, but I really like it as well. How it simplifies and summaries. So it's a good tool. I can show you in a bit. Okay, and container image lifecycle. This is okay. So far, we've explained about how you're gonna scan or make sure your container hosts are fit for purpose. What kind of tools you can use? Yeah, how do you check your vulnerabilities? And we also talked about how you scan your Docker images or container images. What tools we can use, open source, like, and how you address them. So now, on a high level, what's your container lifecycle look like, right? You do a pre-checks, you build your Docker file, you do some analysis, you basically create in your local development environment, you do some testing, right? You build the image and you push it, you scan and you push it to your registry. So once you push it in the registry, so you then the CI pipeline starts. So you might want to test your change, so it automatically if you use familiar with Git, you use Git pipelines to deploy that in a development environment, and you do your test quickly, unit testing, whatever testing you want to do. If you're happy, you promote it further. That means distribute. If you're not happy, it goes back to your development lifecycle. You fix those changes, or you scan again, make sure you fix those vulnerabilities, and then you publish as well. So, and in addition to this, if you're using any cloud tools, so for example, Amazon ECR or something, uh, as part of your Git pipeline or your development pipeline, you might want to do those runs, which I've shown you with the open source tools or Snake, to make sure the image is fit for purpose before you push it to your central image registry like ECR. So ECR or your central repository registry will contain all the scanned or valued tested trial scanned images so that you can promote to your test and production from there. So this is a good habit, or I encourage people to use your container scanning as part of your development pipeline. So that will help you. So yeah, development, deployment after that. So once you have happy with your image which you published in your registry, you might want to scan there as well. So I will show you how it works on the ECR. And then you basically deploy on your test. And again, the cycle you scan, admission checks, and then finally you runtime image scanning. So once you host your runtime image running, you might also want to scan your host right there for any vulnerabilities you want to do. And then, yeah, so application runs. A container destroys nothing but once you want to stop the container. So you basically Docker stop the container and how you want to orchestrate your containers. So that depends on your tool you use. Uh, yeah, so that's on the container image lifecycle. Would quickly point of few services on Amazon Web Services where you want to, if you're interested to run your containers on Amazon Web Services, I would say Amazon ECR is the Elastic Container Registry, where you basically host or save your images in cloud. Amazon ECS is Elastic Container Service, where you would run your containers using this ECS, and it orchestrates as well. Uh, in a sense, if you're familiar with Docker Docker Swarm or things like that, so it basically Docker Compose, it basically orchestrates that container images and how to run, how you want to run, how you want to scale it, stuff like that, how you want to make it, users to be available. All that bits you can completely manage within Elastic Container Service. So EKS is nothing but same as Kubernetes, but completely hosted and managed by Amazon. You won't have access to the host where the control plane is installed or running. They give you an API or endpoint where you can run your pods. You create a cluster and then run your pods or anything on top of that EKS, Elastic Kubernetes Service. Yeah. So those are there's Fargate. There's a couple of other services as well, but I would like to just for a benefit of time, I would like to concentrate on this mainly. And if you're familiar with ECR running on and familiar with how you use it on Amazon Web Services, this is how you would like to scan your images and get notified for your ops team or your dev team. So as soon as the developer push the image in your local registry or the as part of your CI pipeline, continuous integration pipeline, it triggers using a event bridge rule, uh, some scans. So ECR itself have some scanning ability. It scans the image which you pushed and gives you a summary of same, critical, medium, high, low. And based on that, you can create a SNS topic, a simple notification service, which will basically trigger an email to your team. Okay, the image I pushed contains, I don't know, two critical, 10 high, and 50 low. So based on that output, you might want to go back to your development, address those critical ones. Yeah, you define some criteria where you would like to address those vulnerabilities and push it back on the registry again. So this is an automated way how you can orchestrate as part of your complete development pipeline. So this helps the developers to quickly analyze those images without running locally and get notified, and then yeah, look into those vulnerabilities and fix them and push it to the your central repository back again. So this is completely can be managed and triggered within the AWS side. But some of the aspects which I told you, the open source, before you push it to ECR, you can also do that in your GitLab pipeline or yeah CI pipeline here locally as part of your pipeline. So that's on the image scanning using Elastic Container Registry. Quickly on the Kubernetes, I don't want to drill down on the cluster level, how you run on Amazon. I already covered this in our container immersion day. Some of you have joined as well. So here we focus on the security aspects. Yeah. So when you host or when you use Kubernetes service on Amazon, what are the best practices for the security? Yeah. So some of the aspects which we would like to highlight is the identity access management, which is basically authentication, who have access to your cluster, who have access to basically can log into your cluster to run your kubectl and access your pods or what level of access they have. So after you authenticate using IAM, you can also have another level of control within your Kubernetes using RBAC, which I've pointed out previously. You can define those role-based access, role-based controls depending on system masters will give you a full control on the cluster. System discovery, will give us some discovery less privileges depending on your actor. Yeah, so depending on your team, you can also define those authorization concept within RBAC. So pod security, again, you can apply some security policies. You can runtime security. You want to make sure your pods you're running on are secure. Network, sorry, network security. You can apply some network policies as well as when you're running. And yeah, Kubernetes multi-tenancy, I briefly explained before. You can use some namespaces to isolate your resources between your teams, between your applications, to make sure to not to interact with your I don't know Derby or backend, your application to database or stuff like that, depending on your role. You can use multi-tenancy as a segregation of your applications of yeah using namespaces and stuff like that. Detective controls, infrastructure security. I mean, this is mainly managed to a level of by Amazon Web Services, infrastructure security, but it's a shared responsibility, they call it. So anything in the cloud is Amazon Web Services responsibility. Anything on the cloud which you host is your customer responsibility. So you might want to make sure you use a hardened image. You might want to make sure you have some security policies in place. You have a proper IAM access and management in place. Yeah. So those bits, you encrypt your data, use secret manager management. So those aspects you might want to look at as well. So image security we've gone through. So use tools, use ECR to scan your images, make sure they're fit for purpose. Any incident response or forensics that need to be done. So you make sure you can restrict the access on that on that host, give access to uh, yeah to the investigation team or your operations where you would like incident team, management team, where they can get control and see what's going on as well. So yeah, so these are the main aspects I would say to implement on top of EKS clusters if you're running on Amazon Web Services. A few aspects are like when you use uh, managed EKS on AWS, you have some responsibility metrics or from security point of view. One is you know self-managed workers and managed nodes. So here, as you can see, all the orange ones are taken care by the cloud, Amazon Web Services. Anything on the blue on the left side is customer managed, which makes sense, right? So all the control plane, the host related stuff, Amazon makes sure it's highly available, make sure it's secure, you're running. It will take you a headache of you hardening it, because Amazon to a level will make sure it's compliant. Anything that you host in your clusters, like customer data, your images, your source code, yeah, your configuration, how your network, how you manage is basically your responsibility to manage it, and how you would like to do achieve that. We discussed some of the aspect by security policies, network policies, tenant isolation, yeah, multi-tenancy, stuff like that. So RBAC, uh, yeah, IAM, yeah, my configuration, so all that we can do. So these are self-managed. When I say self-managed, your nodes which you're running, it's basically your responsibility. You take care about your OS level, operating system level matches where you're using on the EC2 instances. You manage, you control them. On the managed nodes, basically you wouldn't be able. You don't want to have to worry about where you're running. So this managed nodes will be responsible from Amazon. You basically take care about the configuration on top of it, any nodes which are running on, yeah, network, VPC, worker node scaling, that you define, and you manage anything on top of your application data and your container images. We also have a concept of Fargate, which means you don't have to worry about scaling as well. So this doesn't give you access to the underlying infrastructure. So AWS provision for you, they manage it and they scale it depending on your threshold you define, which is required for your applications to run. So this, it can be also managed, yeah, by Amazon Web Services. As you know, the self-managed is, yeah. So you manage it, you can control. Depending on your use case, some companies would like to have more control on where you would like to run your image, containers. So in that case, you might want to use self-managed worker nodes where you have control. Some companies probably, you run some process and you stop. Yeah, it's not continuously running. You don't worry about where you run on, or how secure the underlying host is. So you might want to use Fargate for a quick process running. So that it depends on your use case. You might want to choose, which direction you would like to go. So yeah, on a high level, this is on EKS side. I just would like to. This is all I would like to cover. But I would like to see if any questions in the chat or anything pop up. Okay. Yeah. So just a quick recap of what we did. We covered most of the aspects on cloud native, a high level, very high level on security white paper, what phases they have, yeah, uh, develop, distribute, and deploy, runtime. We also identified what are the best practice for writing the Docker file. We identified what are the open source tools you can use to harden your host where you run your containers using Docker Bench and Kubebench. They're completely open source and you can download from GitHub. Vulnerability scanning. So we went to another level of security where you could scan your images using various open source tools, including Sneak, which we have a demo. So yeah, we also looked into how you basically minify your Docker images by reducing unnecessary space, unnecessary layers in your images by using Docker Slim. That's open source. And Grype for vulnerability scanning. Learn about image lifecycle, what tools you can use to run on Amazon Web Services, to run your container workloads. High level on how you integrate your image scanning or vulnerability scanning as part of your development pipeline in your wherever you're running on your on-prem to your host in on your cloud using ECR. How you trigger the alerts, notification to your teams, completely automated. What are the best practices for security on hosting on yeah on EKS, and yeah, and what are the different types of offerings they do, self-managed versus Fargate versus managed. So yeah, so that's what I would like to show from my demo. To be honest, on a high level, I would like to share this. One second, a few resources which I would like to also put it on the chat of a few links. But yeah, any questions from the chat? I'm just looking. Yeah, there are a lot of ways to show the security. Yes, start with the security. So I would say, yeah, don't go too deep on how you, if you're starting a container journey, or and you're looking for some container security aspects, start with, a small Docker, build your image, do some POCs, use the open source, use Sneak, scan it, just to a small scale. Don't go to like, Kubernetes with, yeah, 10, 50 ports running it to that level. So understand how the security works on a port level. Understand what all tools we have. You can utilize open source tools. Yeah, that would be a good start, I would say. So I would like to show you some of the sources which I would like to also paste here in the chat. So one of my I wrote few blogs on the container security, so feel free to go here, and also my Medium as well. Okay, we have a question from Nikita. Is there any other way to implement security on Kubernetes except Kubebench? Yeah, of course. I mean, Kubebench just to harden your host where you run your pods here. You have various aspects where you would like to implement security on Kubernetes, which I've just gone through. Like, for example, let me bring back the slide. Multi-tenancy security policies, isolation, network isolation, stuff like that. So it's pretty useful. Kubernetes is one aspect of it, to be honest. So okay, let me. Yeah, but I'll share these resources in the meetup. I'll send an email, or we can share some of the details as well. Okay, another question. When you deploy your application onto many different availability zones, to have availability on all over the world, then those open source vulnerability scanners also provide right quality scanning. Uh, this depends on how you host your application, right? So what happens is you have a web application, for example, some I don't know, some internet site, or I don't know, Facebook, some web application. You make sure your application itself is secure, right? So when you host your application on cloud, two aspects. One, how you make your application more highly available by using different availability zones. You use certain tools, your application load balancers, your I don't know, CloudFront, your content distribution network tools. You might want to use CloudFront. The other aspect is once you expose your application, how you make sure that you won't bring in these vulnerabilities, or there from there on it's more of hack, bad actors looking into explore your application. So which comes in a way like uh, yeah, so users trying to scan your ports on your application, scan any vulnerabilities on your application through the end users. So that's why you need to create a bridge directly not to your application. So maybe you might want to introduce a proxy. You might want to introduce a application load balance, where the traffic will land. You encrypt, and you then divert the traffic again internally from your application to your database and your various services which you would like to talk to. So there are various aspects how you can manage it within the hyperscale. It depends on hyperscaler to hyperscaler. But in AWS, you can use application load balancers. You can use built-in application certificate managers, ACM, to encrypt your data. You can use KMS, a key management service, to encrypt the data at rest for any of the data you database, EBS volumes, your file systems, wherever you store. You can encrypt your data. Yeah, but the scanning, vulnerability scanning comes before you actually expose to the whole world, right? So that's the whole point. So the message here is basically make sure your application is free from any vulnerabilities that the bad actors can get in and hack and cause damage. Yeah, so that's the whole thing. So between your development life cycle, between your development pipeline, you might want to introduce some of the vulnerability scanning tools which we've gone through, and make sure it's hardened. Yeah, please use a hardened image as well when you're creating your hosting your application where you want to run. And once you're happy with those aspects, the cycles which we've gone through, which CNCF recommends as well, on the develop, build, run, those phases which we've gone through, distribute. There you have to make sure you have every quality gate between all those phases. So any phase that you would like to promote to the next one, you should have a quality gate running some tools, running some scans to make sure you have some entry exit criteria between your pipelines to make sure they won't cause any other damage when you go to the host in your production. So yeah, that's a good question. Yeah, you basically make sure you scan on your pipeline using open source. Once you host it in ECR, you can also do another scan on ECR. There's a functionality called push on scan. That's also yeah possible. I would like to show you a command line demo quickly. What I can do. 1 second. Nothing fancy. I have a couple of images on my local machine. I would like to show you to how the scan works from the command line to 1 second. Share. Right. Let me know. You can see my screen. Okay. So here, basically, I would like to show you. 1 second. Do. Right. There you go. I think it's. I'm just checking. Make sure you. It's. Give me a thumbs up if you can see my screen clear. Otherwise, I'll try to increase a little bit, but hopefully, I think it's visible. So I'm typing Docker images. So it gives me a list of Docker images what I have on my local host. Yeah. So I would like to show you, for example, I have Alpine, Hello World, MongoDB. Yeah, these are uh, images which I took it from Docker Hub. So what I would like to do, so I would like to make sure these images, what I would like to use, are not vulnerable to something, yeah, or are fit for purpose for my development. So I would like to scan them to make sure they're okay. So I would use Grip first. Grip has its own vulnerability database which scans the MongoDB Docker image. It gives a nice summary of what vulnerability it has, if it has any, and it also rates what those vulnerabilities are, like this format. Yeah. So what's the severity of them? So I'm using Grip. It's open source. You can install. It's there on the blog which I shared you as well. How to install and how to get those tools. I'll also share some links in a bit. But yeah, so it's a nice summary. So these are all the vulnerabilities you can see, and it also ranks how severe they are. So if I'm not seeing any critical or high, yeah, to some extent I'm okay, but you might want to scan the medium ones as well. But as you can see, it looks I don't have any critical and high vulnerabilities in this MongoDB one. Yeah, so I want to use Docker scan as well on this. Behind the scenes, it uses grip. Sorry, Sneak, Docker scan, and Mongo. Okay, so I need to log in. Okay, I haven't configured here, so I just skip this. I can use Trivy. Trivy is another open source which I've shown you on the presentation. So what it does is it scans the image, it gives a nice tabular format on the same image, so Docker, sorry, MongoDB. So as you can see, you can have the same result. There's no critical or high, and what it also gives you a nice title on that vulnerability, so where you can go investigate more to understand the vulnerability, how you fix it. But yeah, so this is a nice neat tool I like to use. I use this as well. Trivy. It's open source. You can deploy, install on your host, and you can. The beauty of these things, the reason why I'm showing is, as part of your pipeline, it's very easy to integrate these scans when you build your image. This would be the output of your development pipeline, and based on these results, you can also have some exit criteria to push this image to your registry. Yeah, so this is really useful. Okay, so I would also like to show you Docker Slim. Docker Slim, as I said, it scans your image and it identifies what layers you have, and you can assess them. You see, okay, what's important, and basically you can also reduce the size of your images as well. So as you can see, it creates a lot of information on the layers, what this image have, yeah, what kind of versions, yeah. So very human readable in a form. But this is also pretty useful when you would like to reduce your size of your images. And finally, we have one more. Yeah, we use Trivy. Yeah, just about time. Yeah, I would like to. I will do another scan on Hello World. Yeah. So okay. So there you go. So it just scans that image and just gives you info. It's very small image, so it doesn't contain much. But yeah, so I would stop here because we right on time on 11:50. So I would move this and see if you have any other questions on what we gone through so far. Cool. Any other questions? What do you use on your production workloads? Any real-time issues you're facing, or any of your, yeah, any inputs you would like to know? Any use cases you would like to discuss? Yeah, feel free. But pretty good questions from Nikita, Chaba, and a few of you guys. Thank you. There's one question came up. So those are the SaaS tools, right? Right. So some of Some of the aspects, yes, they are. What you meant by SAST and DAST is some are like constant static, and some are like dynamic. Some of the which changes with real world threat. So some of the tools you use are kind of static, but some they also upgrade their database as and when the new threats are introduced. Most of those vulnerability tools they include them in the database as well. So it's not like they more of a static, but you could also use them as yeah on the yeah, dynamic application testing as well. But it's mostly yes, static application security testing. That's what you would run in a way. But you have to make sure if you're hosting any ClayDB or Encore, you want to make sure that your database is up to date. Otherwise, it cannot find the vulnerabilities if you don't update your database. Yeah, it's very important that you update your vulnerability database. Or if you use tools like Sneak or anything which is or software as a service kind of or cloud hosted ones, they will make sure they have up to date vulnerability database. And then yeah. Okay, there's one more question. We can scan images weekly, but difficult to act on those. Yes, when the image is not in active development anymore. So retesting. Any good practice you can recommend? Yes, that's a good question, TT. What this is whenever you have a vulnerability or found any issues with your development pipeline or on the image, it's good practice you develop some automated testing as well, because if you have any manual testing, you have waiting for some resource to act upon manually based depending on the result. It will always be time, it will always be difficult, yes. But what I would recommend is, as you've seen some of the slides, what CNCF recommends, you should have some automated test scripts or auto remediation as well, depending on common issues, common things. In cloud world, you have some auto remediation, a concept which you can achieve depending on common config issues. Someone thing, if you find, for example, a bucket open to the whole world, yeah, so you just lock it. Or if you have this file contains a password or sensitive information, yeah, so delete it or remove it, stuff like that. So there is some automate remediation things which you could implement. But yeah, so when the image is not active, which means you don't have to wait to run those images or containers. You can also scan those images before you even run on your host, right? So that's the best practice which we would like to recommend. So any of within your development pipeline, one of the stage would be after you create a Docker build and get a Docker image, run some open source tools, run Snake, run some of the tools to scan your images, find your vulnerabilities before you push into your Docker registry or container registry, and then fix them back. It goes in a cycle that way. But that's a good practice is find some auto remediation test auto or test automated test on top of your development process before you push it to your central registry. I would definitely suggest to read that white paper. It covers a lot of bits which I didn't cover because of the time. But I definitely would suggest these aspects. They covered a lot of bits in the CNCF white paper. We have one more from Monji. The real world scenario, because before remediation, any CVE, does it require approval from the SecOps team in an organization, or typically DevOps simply go ahead and updates it? That's a good question. Whenever we have any security vulnerabilities as part of your development cycle, it would be DevOps, yeah, DevSecOps or DevOps, you call it. You have to make sure that cycle is automated within your pipeline. So, but before you host it in your application, but so before you goes to the production or your going in your test, that's when you need another stakeholder from your operations to make sure okay, they've done some tests, they're happy, so just a click of a button, and then maybe they deploy in your test as well. But this should be part of your DevSecOps life cycle, yeah. So you have some remediations, you fix some CVEs. You don't need approval for your dev to test it, make sure it fit for purpose, yeah. So that's up to your development team. That should be continuous integration. But as soon as you want to move to production, you might want to involve some of the operations folks to have a give a heads up or approval process depending on your change control, change management process, how you organization have. Yeah, you might want to adopt that depending on your company standards. But the good practice would be working very closely with operations, make sure they understand your your CI process, how you address those vulnerabilities, how you scan them, so they appreciate. I mean, obviously, the more security vulnerabilities you fix, it's your security team will be more happy. So yeah, that's a good question. Okay. Yeah, if you have still more questions, feel free to join our Discord community, please. It's a very vibrant community, I would say. We do have events coming up, across various topics, various security topics. We have a lot of expertise from various around the globe who can also actively involve as well. So yeah, I would definitely suggest joining the community to learn more or share your knowledge as well. Some of the experts here who have knowledge that would be a very good community. Yes. So we have 1 minute left. I would say, uh, yeah, thank you for everyone who joined today. I can recognize some of the names as well who followed me from the AWS events as well. I really thank you, everyone, and who joined part of the DevSecOps, the new members as well. I'm really thankful and grateful for you guys. I would, yeah, we would shortlist some of the guys who stick to the event, and we would publish them. We will reach them with the AWS vouchers, and yeah, we will. Yeah, hopefully you will continue your journey on the container topics on various topic security aspects. I'm looking forward for coming events as well, and yeah, that's the message. For me, I'm really glad that we have a good audience, good questions, and hopefully we did well. Or yeah, maybe you will take away something from here, some security aspects, something new maybe, and we can still be in touch on our Discord channel, and we can happy to help or share more information there. Cool. In that case, yeah, I I would like to say thank you everyone, and I would yeah, thanks Santosh, thanks you Manjit, Nikita, thanks you Tale. I would really appreciate Tale getting up, 5 a.m. in the morning his time from Brazil to support me in this event. Sam for helping me in this event from behind the scenes. The whole DevSecon community is really wonderful. How they support each other and bring value to local communities. So thank you, Sam, thank you, Tale, thank you, DevSecOps team, and thank you, the audience. You've been a very wonderful audience today. So thank you, guys. I will send the vouchers separately to the shortlisted candidates in the meetup emails or in the DevSecOps, and if I see you around, but you will receive them, yeah, today sometime for sure. So thank you, guys. Have a good day, and I'll look forward for coming events to, yeah, see you guys again. Bye bye.